So get into your group. And 30 minutes for this worksheet, and then we'll start the next topic.
What is the next topic?
Tangent planes and chain link.
How many questions?
5.
Okay. So we each did one.
You were showing an effort, he actually like worked with you.
Yeah.
Which I appreciated because I was like, all right, all the people that don't actually want to be here aren't going to be here for very long.
Tangent planes very similar to tangent lines, except tangent lines for curves, tangent planes are for surfaces. Right, so it's just a plane that is tangent to a surface at the point. Right, more formally, it is the plane that contains all of the lines that are tangent to the surface at that point. Right, so it's a collection of lines. And that's the equation of the tangent plane. So total differential, if you have a multivariate function, z is a function of, say, n independent variables, then the total differential is just the sum of the partial of f with respect to each variable times the differential for that variable. And then we have the chain rules for multivariates. So starting with two-variate, let's say that z equals f of x, y, where x and y are both functions of an independent variable, call it t. Then z is also differentiable with respect to t, and those should not be partials. For the z, that should be dz dt. Right, dz dt would be partial z partial x times dx dt plus partial z partial y times dy dt. And that, of course, can be extended to three-variable whatever, where each of the independent variables of z is also a function of a single independent variable. Right? Then, if it's more than two-variate, right? So you have a two-variate function, z is a function x and y, where both x and y are functions of two independent variables, u and v. Then z is also differentiable in both u and v, and you have the similar thing.
How come for this one there's no dx dt?
Because now x is multivariate. So it has to be a partial because it's multivariate. Whereas here, they were single variate. And in general, this would be the general chain rule. W is a function of m variables, where each of those m variables are functions of n variables. Right? Then W is differentiable with each of those n's, the ti's. And the partial W, partial t sub j is that sum So that's just in general. Who remembers implicit differentiation?
What?
Implicit differentiation from Calc 1. You don't remember it?
No.
Or you don't like it?
Both.
Well, how can you know if you like it if you don't remember it?
That's probably a reason why I didn't remember it.
That's one
Close it off.
They get it.
Guess what? We can have an implicitly defined multivariate function too. So implicit differentiation is back.
We gotta like it better.
Probably because it's actually easier now. So this is your implicit differentiation from Calc 1. Well, just say that your implicit definition is a function of x and y that equals 0. They do y dx. Instead of doing all that stuff you had to do in Calc 1. Just that. And then, of course, you have, if it's a two-variable function that's implicitly defined, you have similar implicit. I mean, you can still do it the old-fashioned way, but you can also just do it this way. And again, this can be, I don't know, I don't have it. This can be extended to if it's like a 5-variant implicitly defined. You have similar things. Remember, 5-variant means you're going to have 5 independent variables and 1 dependent. I think I mentioned it, right? 2-variant function is 3-dimensional. Right? You have 2 independent variables, your x and y. That's your xy plane, and then z gives you your third, which means a 3-variant is 4-dimensional. It's the XYZ space, and then W would be the 4th dimension, which would be perpendicular to all 3 X, Y, and Z. You just can't visualize how that's done. Which means 5-variant is 6 spatial dimensions, so on and so forth. Total differential. That's how you find a total differential. So what is partial z partial x?
X squared y plus 2x y squared plus y cubed.
Partial z partial y.
Plus x squared y plus 3xy squared. G.
Look real closely. It's so obvious, if there was any more obvious, they'd kick you in the nuts.
Would it just be 3y squared? No.
You're missing a 2.
Where?
It should be 2x squared y.
I said, if there's any more obvious, just kick you in the nuts. Right, so what is partial with respect to x?
Sine y minus y cosine x.
And what is the partial with respect to y?
Or x cosine y minus sine of x.
Yeah, there's total difference. Find the spherical partials for a function. Well, in spherical, your three independent variables are rho, theta, and phi, right? What is x in spherical?
Cosine.
So what is x in spherical?
Phi cosine of theta sine of phi.
Phi.
Or phi cosine of theta sine of. What's the first? It's delta f, delta, I'm forgetting the Greek word.
You don't know your Greek? You don't know your Greek alphabet?
I'm black, yeah, I don't know all of the Greek alphabet.
And this is why I don't like you engineers.
Crucify me, I don't know the whole Greek alphabet.
It's unacceptable.
Oh no.
It's rho. You redeemed that a little bit by knowing that.
I was kind of
Rho cosine.
Actually, you redeemed a little more because you were sitting there watching him squirm, so you get points for that too.
oh cool.
And then y is rho sine of theta sine of theta. row, because
All right, do give me points for not calling it P. So you do get points for that.
yeah, I would never. That's good.
I had someone keep calling it P, and I went up to her one day, I said, look, if you call P one more time, you're just gonna fail my class. And I'll make sure that I follow you, you fail everyone.
You ever heard alpha referred to as fish?
Yes,
That's gotta be my favorite.
But actually,
I think it's so funny.
alpha's not really fish looking, it's the proportional that's fish looking. Just a lot of people draw their alphas to look like the proportional symbol. Because it's really hard, the tails aren't supposed to be that long. Like, technically speaking, that's not an A, that tail's too long. More like that, is an A. Same thing with alpha, the tails aren't supposed to be super long. But that's, of course, just mathematical semantics.
That slide, array.
Yeah, calling alpha the weird fish is the funniest thing.
So let's start with partial F, partial rho. What Greek letter is it? Good job.
If I didn't know at that time, that would have been bad.
Chain rule. Right. Partial of F with respect to X times partial of X with respect to rho, plus partial of F with respect to Y times partial of Y with respect to rho, plus partial of F with respect to Z times partial of Z with respect to rho. What's the partial of F with respect to X? Partial of F with respect to X. What is it? It's a trick question. You don't know what it is, because F isn't given.
Okay.
So it's just the partial of F with respect to X.
So it's just confused.
You don't know what it is.
Well, yeah, that's
Right, so it stays partial of F with respect to X. What is the partial of X with respect to rho? So partial X, partial rho.
Oh, cosine of theta, sine of theta.
Partial Y, partial rho. What
You say you said P.
No, P.
What about partial z partial rho?
Just cosine.
And that would be the partial with respect to rho for a rectangular function. With respect to theta, again, chain rule. Partial x, partial theta.
Would have been just the same thing, but you just take out theta. P sine theta. Or sorry, sine rho. Sorry, rho sine.
Negative sine theta, sine 2.
What about y with respect to theta? Oops, slide. Correct. So partial y, partial theta.
That's just multiplication, not dot product.
Right, that's multiplication. Can't be dot product's only for vectors.
Yeah.
This was hard. This is probably the hardest thing to do all day. What's partial z, partial theta?
I'm gonna say rho cosine.
That was just zero. No, wait, it's only just like this. Oops.
And that would be your partial with respect to theta of a rectangular function. Again, chain rule. What is partial of x with respect to phi?
Rho cosine theta cosine.
What about y?
Rho sine theta cosine theta.
And z?
Negative rho sine theta.
And there's your partial with respect to phi.
If we use spherical coordinate, how come it's for rectangular?
You'll get a rectangular function like one of the partials in spherical. Right, so you could first convert it to spherical, or use those. We're given a function. Evaluate the three spherical partials. No, I don't want to use slide. What is the partial with respect to x? You need those three partials. So what's the partial with respect to x?
2x plus 2y squared plus 2z squared. Just 2x.
What about with respect to y? And with respect to z? Howard, what's wrong with those? Huh? Not converted to what?
Spherical.
That's not spherical. Convert to spherical. What is use of x in spherical?
Rho cosine theta sine theta.
What about use of y in spherical? What is it?
4 sine theta sine theta.
That? Missing a what?
Or, what?
And what about use of z?
4 rho cosine.
Starting with u sub rho. Right, so partial u with respect to rho. That's going to be cosine theta sine phi times ux, right? And it was plus sine theta sine phi uy plus cosine phi uz. What did we say ux was?
Oh, 2 rho cosine theta sine.
What was uy?
4 rho sine theta sine.
And what was uz?
4 cosine
That? That poor bro. Everyone always forgets it. Or they forget its name.
I just keep on thinking about the P, and then I just,
This is going to give us what? 2 rho cosine squared theta sine squared phi plus 4 rho sine squared theta sine squared phi plus 4 rho cosine squared phi. Can that be simplified in any meaningful way?
take that up after 2.
Is that really gonna help? No. If you factor out a 2 row, it's not gonna help. There's really no meaningful simplification. So I'll just leave it like that. Use of theta, where do we say it was? Negative rho, sine theta, sine phi, ux, plus rho cosine theta, sine phi, uy. And nothing else, right? For sub theta?
Zero, zero.
Huh?
We really have the x and y components.
Because z sub theta was 0. And ux was what? 2 rho cosine theta sine phi. Uy was 4 rho sine theta sine phi. Well, that could be simplified. Is there another meaningful simplification we can make? I'll give you a spoiler. Oh, that's making sense.
I noticed that cosine theta, sine theta, sine system, I'm not sure what you
Sad. You make me half sad. At least you know that the sine theta and cosine theta is going to simplify.
make sure to get what.
Half sad.
It's a double angle, right?
Double angle identity on what?
It's a couple of things.
I don't even remember it, to be honest.
Sad.
It's like 2 something. And, yeah, there you go.
Yeah, that's right.
Sine 2 theta equals 2 sine theta cosine theta. Double angle on sine.
In the second one, right at the edge, where's the 4 come from? In the second line, right at the end, in the parentheses where you're subbing in,
Mhm.
you said y. Where is the 4 row? I mean, you have 2.
What was UI?
Oh, okay, yeah, I just wrote it wrong. Got it.
There we go. That would be U theta. And what about U phi? This was what? Rho cosine theta cosine phi ux plus rho sine theta cosine phi uy minus rho sine phi uz. Yeah, sine phi. That's a cosine. Distribute, we get that, right? Can we simplify that? What does that simplify to? Well, let's do it one step at a time, right? Double angle for sine. There's a rho squared sine 2 phi common. Left with what? That? I can simplify. Who sees that?
Plus 1 cosine squared plus 9 Cosine squared and sine squared. You want that?
Well, that's true, that's a cosine squared of 2 sine squared. You're on the right track. Sine squared minus 1 is negative cosine squared. There's your fully simplified partial derivative. This is why trig is sexy. We're getting close to the point where we're going to make once you crush up one trig. So we're going to start using it a lot. Implicit differentiation here. 2 ways you can do it. You can just do the brute force method, right? Or write a 3-variate function equal to 0 out of that expression. We need all 3 partials because they want partial z, partial x, and partial z, partial y. What is the partial of f with respect to x?
Cosine y plus cosine 16.
Be that, right? And y? That, right? And z? Would be that, right? That is what partial z, partial x will be. And we said fx. Was that right? And FZ. What's that? And sadly, I don't think that can be simplified. Not in a meaningful way. And then again, by implicit, partial z, partial y, negative fy over fz. What do we say fy was? That. There's your two partials. Which is a lot easier, I'll leave you to try and brute force that using the Calc 1 technique. And show that after a lot of algebra, you get the exact same thing. The next thing I'm going to keep out of here is the result. I won't actually prove this for the sake of time. And this is for surfaces given in the form of f of x, y, z equals 0, so implicitly defined. Right, not z equals something. This is an implicitly defined surface. I'm going to show that the two surfaces are tangent at, that shouldn't be to the point, at the point 2, 1, 1. Well, if the surfaces are tangent at that point, then their tangent planes would they have to be parallel at the point. So find the tangent plane for both f and g. And in fact, the tangent planes have to be identical. Right? So the tangent at the point of touching at the point, right? So the tangent planes would actually be the same plane. But all I have to do is show that the tangent planes are parallel. But that would mean that the normal vectors for the two planes are parallel. That's what we want to show. So we'll find the normal vectors for both F and G, the tangent planes, which, by the way, is also going to be normal to the surface, by definition. At the point 2, 1, 1, and show that they're parallel. Well, the normal vector if you look back at this result, would just be those partials, right? X component of the vector, y component of the vector, z component of the vector. Right? Remember, it's the coefficient of x, y, and z. Right? Back to when we studied planes. What is f sub x? Correct, 2x. That's to be evaluated at your point P. What is f sub y? And what is f sub c? The point was 2, 1, 1. So what is our normal vector?
2x, 4. Here we is 4, 8.
I'll just factor out that for you as well.
So this is to prove that the normal vectors are parallel.
Which proves that their planes are parallel, which would prove that the surfaces are tangent.
So right now, we don't know if they're parallel.
Well, I mean, we do. Because it said show that
Okay.
they're tangent.
That's what I was.
Same argument.
So this is just a lot of saving
Well, essentially, because what I'm doing is I'm showing the tangent planes have parallel normal vectors. Right, so without going through the process of actually finding those tangent planes, I'm jumping right to finding the normal vectors. Using that result which I had proven for the sake of time.
So I guess would we have to like go through the whole steps and we just do this?
No. Just do it. What's G sub X? I could.
Did you show the previous one?
I could.
We showed the previous one. It's 2x minus 6.
What about Y?
Two y minus 6.
And what about Z?
2c minus 2, or plus 2 really.
Now evaluate that at 2, 1, 1. What do you get?
Negative 2.
What do you notice?
There.
What the hell just happened? So what do you notice about the two normal vectors? How does NF and NG compare?
They have the same scalar vector.
True. Be more specific.
They have the same,
What does it mean for two vectors to be parallel?
they have the same vector, but different.
Well, not really. I mean, you could, with some manipulation, get the same base vector, but there's a more succinct way of saying it. Hmm?
To test for if they're parallel.
What is it? Multiple? Yeah, one's a multiple of the other. One's a scalar multiple of the other. -2 times NG, doesn't that give you NF? Which proves that they're parallel. based on what we stated earlier, that proves that the tangent planes are parallel, which proves that the surfaces are tangent at the point, so we're done. I'm going to show that these two surfaces intersect at a right angle at the point 1, 2, 1. What we have to do, so if we want to show the surfaces are normal to each other at that point, what are we going to do? So what can you say about their tangent planes?
Not parallel.
Hmm?
They're not parallel.
True.
Perpendicular.
The planes would have to be perpendicular or normal at that point. So what can you say about their normal vectors? So if two planes are perpendicular, what can you say about the normal vectors?
You should be multiples.
That would be parallel, which you just did.
And they also reflect this shows the perpendicular.
They would also be perpendicular. So the strategy is the same as last problem. Find the normal vectors and show that those normal vectors are perpendicular. How would you show that two vectors are perpendicular? What's about the dot product? Yes. So that would be the general strategy for this. Find the normal vectors of the two tangent planes, take the dot product, show it's zero. For the sake of time, I'm not doing it. But that's the general strategy. Any questions? Seventh homework is due Monday. Second group assignment is due the following Monday. All right, don't forget to start filling out that green reference sheet. Third quiz will be available at the end of class today. That will also be due Monday. And a reminder, we do not meet next Monday. It's a holiday weekend. This is our last holiday weekend of the semester.
When is our next, exam?
After the holiday, I don't know the exact date.
So, where that Wednesday?
I don't think it's that Wednesday. I didn't say directly after the holiday, I just said sometime after the holiday.
Yeah, don't say that, bro.
Let's put it this way.
The 23rd.
Let's put it this way. I haven't written the exam yet.
So, 23rd.
Right, so it's not going to be next week. Maybe the week. No, I don't think it's the week after either, is it?
Next.
It's,
Yeah, I think it's 2 weeks.
If my calendar is correct, it's the
Yeah, I think it's 2 weeks from today. I think. But again, it's on the syllabus.
Yeah, I think my calendar is correct, because I'm pretty sure I'm looking at this.
All right, so get into your group. Now, this worksheet does also go over linear approximations, which I don't cover in class. But I was nice enough to put the definition on the worksheet. For those of you that didn't read the sections, which I know none of you didn't do that, I know you all rather read the section. So I know you read the sections and watch the videos before coming to class. But it's there for you.
I've seen ones and just not to see it.
What?
I've seen the videos, just not to see it.
I'm telling you, it sounds like it'd be such a stupid superpower, but if I had the power to